Battery cell production starts with electrode mixing processes. However, have you ever thought about the steps before cell production? All raw materials and components, such as housing, electrode and separator foils, liquid electrolytes, solvents, and powdered electrode materials must be stored and transported in a gigafactory. This can be especially challenging for powders, as each powder may demonstrate a unique flow behavior. Powders can act free-flowing like coarse sugar, or behave cohesively like wheat flour. These behavioral differences are a result of the particle size, particle shape, material composition, and ambient conditions. So why do powder properties even matter? Principally, they determine the required processes for each handling step. For dusty materials, safety precautions must be considered during delivery. Other materials can create challenges while conveying and dosing. Therefore, we in Work Package 4.2 develop general guidelines for powder handling in battery gigafactories. In order to design plants and processes, the powder properties must be known. Exemplarily, we performed shear tests, Hall friction tests, and time consolidation tests on the Gigabat reference materials. These tests help estimate the expected powder behavior and are necessary for proper silo design. Shear testers, such as ring shear testers, are used to determine properties like the flowability or the effective angle of internal friction. For a shear test, the shear cell is filled with powder and weighed. The shear cell is then covered with a lid, which is used to apply normal force and measure shear stress. During the measurement procedure, the powder is sheared under defined shear stresses and states of consolidation. Thereby, we can determine the flow properties of a powder. Besides the flow properties of a powder, we need to know how it interacts with silo walls in order to design silos accordingly. The interaction is measured by shearing the powder over a wall sample at different normal loads. The resulting shear stresses are then used to calculate the wall friction. Based on these measurements, mass flow silos can be designed. In well-designed mass flow silos, materials leave in the same order as they enter. As a result, raw materials can easily be tracked up to production. Preventing funnel flow ensures a continuous material supply with high quality. Our work can help you design proper powder handling processes in your gigafactories. This ensures consistent material supply and thereby enables high quality and efficient battery production.